Now, we already touched on all of these learning objectives, and each flowed really nicely from one concept to the next. Now, it's time to conclude our chemistry of biology discussion by touching on something not as directly related to these other learning objectives. Now, we will discuss concentration gradients, diffusion, and osmosis. One thing that all three of these have in common, which is why they have their own separate discussion, is that they all have to do with the transport of molecules. So let's start out by learning about the term concentration gradient. First things first, what does the word concentration actually mean? Concentration refers to the relative amount of a substance. So if we had two pitchers full of water and salt, if the pitcher on the right had 40% salt, let's say, which would imply that there is then 60% water, and the pitcher on the left, let's say, has 10% salt, meaning that there is 90% water, we would say that the concentration of salt is higher in the pitcher to the right. Even if the pitcher on the left is 100 times larger than the pitcher on the right, meaning it physically has more salt molecules in it, the concentration of salt is still higher in the pitcher on the right because concentration refers to relative amounts, right? The percent salt is still higher in the pitcher on the right. Does that make sense? All right, now that we've got concentration under our belts, let's go ahead and talk about concentration gradients. Have you ever gone to PowerPoint and inserted a shape and then told the shape to have a gradient fill to it? Kind of like what I'm demonstrating on the screen. Well, I want you to think about concentration gradient similar to this visual. Let's break it down. This is a color gradient, right? On one side, there is less color than there is on the other side. A color gradient. So if we are looking at a concentration gradient, that just means we're looking at a gradient where on one side there is a lower concentration of something, while on the other side there is a higher concentration of something. Now, usually when we are discussing concentration gradients, it's in reference to a solution of something. I'll let our friend here give you more details on that front.
Alright, so what we're going to be talking about really quick in this little snippet is the idea of concentration gradient. Now, before we get to concentration gradient, let's just take a quick review and go over some terms. We are going to make a solution. We're talking about things in a solution. So to make a solution, we must first have a solvent and a solute, remembering that the solute is what gets dissolved in that solvent. So water is our universal solvent. So in this case, our stuff here, that would be our water, and we have to put solute in it, such as salt or sugar, to make a solution. So these particles here, these are our solute particles that dissolve in our solvent. And not only dissolve, but it's actually going to spread out once we pour our solute in our solvent. And that's a way that a solution is created. Okay, so the solvent dissolves the solute. So let's move on to concentration gradient, because that's really the key to this whole little clip here. Let's talk about the idea of concentration gradient. Particles, whether it's a water particle, gas particle, nutrients, when they're very, very small, they like to move from an area where there is a lot of them, a high concentration of them, to an area where there's not a lot of them, or a lower concentration of them. And when we have an area where there's a lot of them and an area where there's not a lot of them, we call that a concentration gradient, right? And particles always want to move from where there's a high concentration of themselves to an area where there's a low concentration of themselves. And if we think about it, people do this too, right? If you're in a crowded elevator, you would rather go out of that crowded elevator. And that's kind of like diffusion of people, right? The elevator doors open and people leave because it's more comfortable. So in this example that you see here, at the very top, the particles over on the left want to move towards the area on the right. We say that they want to move down their concentration gradient, right? Because they're moving from high to low in terms of that concentration gradient. So down their concentration gradient. And this happens naturally. It's something that occurs naturally in nature and does not require any energy. Particles, quote unquote, want to do this. Here we can see an example of what's going on. On the left, if you focus in at the very start, there is lots of particles on the left side and not as many on the right side. The left side we would call a high concentration. The right side we would call a low concentration. Now, in this case, they're able to move across the membrane, and when they do so, they almost always move from high to low concentration, right? Now you might say, well, hold up a second, they actually seem to be going across the other way too. But that's because particles move randomly. Their movement is random, but they do, quote unquote, want to or tend to move from high to the low. And they will continue to do that until they reach something called equilibrium, where there's a balance between the two sides. So the flow goes in both directions randomly, but the net flow, where the majority of the flow happens, goes from that high to low. So at the very, very end of this example, you can see that they are at equilibrium, very briefly, where we have the same concentration of molecules on each side. Now, will the particles ever stop moving? No, they will keep moving actually. They'll keep trading places back and forth even when they're in equilibrium, but they'll move back and forth at the same rate if they're at equilibrium. Okay, when they're not in equilibrium, when we have a high concentration on one side and a low concentration on the other side, they're going to want to move from the area of high concentration to the area of low concentration. No energy required. It's a natural process that happens.
So now, circling back and diving into your next check-in question, this is check-in number 29. Complete the sentence. If your friend were to tell you that the blue particles, shown here, are moving down their concentration gradient, that would mean that the blue particles are... Okay, so that's concentration gradient. Now let's build on this to discuss diffusion.